Hello, and welcome to my physics waves presentation. There are two types of waves. The first is a longitudinal, and that is when the disturbance is parallel to the propagation, or the direction of propagation. And the second is a transverse. A transverse wave is when the disturbance is perpendicular to the direction of propagation. Now, transverse waves have crests and troughs, while longitudinal waves have compressions and refractions. Here we have a longitudinal wave. As you can see, the medium here is the pistons, and the disturbance starts on the right and then moves through the pistons all the way to the left. Now it's a bit laggy, but if you look closely you can see each piston moving one at a time from the right to the left in succession. You can also tell that it's longitudinal because the disturbance gets sent through horizontally through the pistons. That's why they extend. You can see them extending to their right, but actually here we have my pride and joy. This took me a very long time, so study up. This is a transverse wave, and you can tell that because as the minecarts move left to right, and the minecarts, by the way, are the medium, they move left to right, which is horizontal. The force are the pistons, which is vertical, so those are perpendicular to each other, and thus you have a transverse wave. Alright, let's look at things in more detail. Well, let's start with frequency. The frequency of a wave is just however many waves there are for a given time, and that's given in hertz. And a period of a wave is however much time elapsed over a certain number of waves, and that would boil down to however many seconds there are per wave, and that's given in seconds. As you can see here, frequency and periods of the waves are inverses of each other, which means that frequency equals 1 over the period, and likewise period equals 1 over the frequency. Wavelength is just the distance between each crest or each trough, so crest to crest or trough to trough. And velocity is given by the frequency times the wavelength, and it's given in meters per second. Alright, if you're saying, what are you talking about? Let's look at Minecraft. In Minecraft, just look for the minecart, because that'll symbolize the wave. Now, I did some counting, and the wavelength between each crest is 39 blocks, and the amplitude is 9 blocks. Now, amplitude is just the height of the wave over 2. Use a timer to time the minecart to get the frequency to be 0.41 hertz, and because of that, I got the period to be 2.43 seconds. And the velocity, since we know the wavelength and frequency now, is 16 blocks per second. Now, refraction is what happens when there's a change in the media of the wave. And the two things that change for the waves are their wavelength and their velocity. Now, if you remember from the velocity equation, this is because velocity equals wavelength times frequency. Now, if velocity and wavelength both change, then there has to be a constant, and the constant is frequency. As you can see here, the speed of light is equal to 3 times 10 to the 8th meters per second, and we can use that to find the index of refraction, which is equal to the speed of light over the velocity. And as seen in the diagram below, between the two different medias, which is the horizontal or x-axis, and then the normal line is perpendicular to that barrier, and it's just used as a reference. Now we have our first index of refraction, Ni, and the second one is Nr, and we have our wave, which is coming in at 20 degrees, and it comes out at 9 degrees. And we can apply it to Snell's law, which allows us to find any unknown variable, given that all the other variables are known. Here the white line represents the wave, and the blue box is water. The gold line that's perpendicular to the water is the normal line, and above that box is going to represent air, so a wave is going from air to water. Refraction is when waves travel around or between barriers, and what changes are their shape and direction. As seen here, the slit width, or the barrier that they need to travel between, directly affects how much diffraction occurs. Minecraft can do a better job explaining. Although not very obvious, the one on the left diffracts more than the one on the right, because if you look, the one on the left has a smaller slit width of 3 blocks. Lastly is interference. Interference happens when two waves are in the same medium and they collide and pass through each other. Now there are two types of interference, constructive and destructive. Now let's look at Minecraft. As you may have noticed, the two waves' amplitudes were added together And this is an example of a constructive wave. Constructive waves happen when the two waves' amplitudes are added together and then they pass through each other, versus in a destructive wave, the two amplitudes are canceled out and then they pass through each other. That sums up about everything. Good night.